Hi everyone, in this video I'll try to solve these three differential equations using Simulink in MATLAB. The three differential equations are given with the initial conditions and with the t range from initial 0 to final of 1. Let's have a look on the final solution on Simulink. This is the final solution of that system of differential equations. It looks a bit complicated, but after watching this video, I hope that you're gonna find it simple and easy to work with. So let's start from the beginning. The first thing to do after double-clicking on the icon of MATLAB on your desktop or your start menu, you'll have the MATLAB started. Choose that little red circle that you see here because this is Simulink. After you click on it, you have that window. That window is the Simulink library browser. It has certain icons as you see here. These icons are called blocks. So I'm gonna call each one a block. Each block here has a function, and we'll see how does it work after a while. There are some categories on your left here. This category is called the commonly used blocks. We're gonna use it a lot. So to start with, you have to press on that new model so that the workspace window will appear to you. I'm gonna call it workspace because we're gonna put all the blocks over here to work with the system of differential equations that we have. The first thing to deal with is that integrator block, because that integrator is the solution of a differential equation. If you have dy by dt, for example, and you insert it into that integrator, the result of it will be y. So, since I have three differential equations, I will need three integrators into my workspace. To do so, I'll press on that integrator, keep your finger on the click of the mouse, and then drag and release it in your workspace. Do that move 3 times so that we get 3 integrators in our workspace. One is for y, the other is for x, and the last one is for u. Just to remind myself that I chose this one to be y, this one to be x, and that one to be u, I'll drag an arrow out of the output of the integrator and release again. I'll have that red disconnected arrow. That means something is wrong here because this arrow is not connected to something else. Keep it for the moment like this, but after we finish our solution in the Simulink, it will look connected and it will look black. So that means after a while, after we finish all the solution of the system, it's gonna be correct. For the moment, just keep it like that. Double click on the arrow and write y. Just to keep in mind that we chose that one for y and the second one for x and that last one for u, so that you won't forget and you'll have everything clear to you. Okay, now have another look upon your three differential equations to see which one of them is the simplest. In my example here, I have dx by dt as the simplest one, since it's only 5y. So I'll start working with that one. So I need to multiply that y here by a 5 and then insert it into the integrator of dx by dt. To do so, I'll choose that gain block. This block do the multiplication process. I have a value of 1 on the gain, but I need it to be 5, so I'm gonna double click on the gain and change that value of 1 to 5 and then press OK. I get the gain value of 5 that I want. Now I have to insert that y into the gain and then take the output as 5y and insert it into the second integrator of dx by dt. So I'll do just that. Start from the input of your gain and connect it with the y, wherever the y is. Then have another arrow and connect it with your x. You can't just release the arrow wherever you want and reconnect it again excuse me, to get the shape that you want or the pathway that you like. Now I have it ready. This arrow here carries a 5y in it, so I'll double click on the arrow and write 5y, just not to confuse myself. After that, I get my dx by dt ready, so I'm gonna work with the dy by dt. Sorry, du by dt. Du by dt is 2x plus 2y. So I have to get my 2y and 2x before inserting them and sum them up before inserting them into the dy by dt integrator. To do so, I guess you know now what to do. Of course, we're gonna drag the gain and drag another one near the x. If you drag it to the exact correct place near the arrow, it's gonna be connected automatically. So I'll change the value of the gain to 2 over here, and also for the y to 2 again. I'll have the result of this one as 2y and of this one as 2x. Now the thing is, I have to sum these two strings together, or these two arrows together, to get 2y plus 2x. To do that, I'll use another block that is called sum, that circular one. So I'm gonna drag it, put it here. This one will do the summation of the two arrows that's gonna be inserted into it. So I'll connect the y, and I'll connect, or the 2y, and I'll connect the 2x. Okay, now the output arrow of that process here will be 2y plus 2x. I'll write it not to forget. By the way, this sum block can be used for subtraction as well. If you want to do that, double click on the sum and change the list of signs that you have here. I have two pluses. If one of my processes was minus or subtraction, change that sign to a negative, and it's gonna do a subtraction for you. But in my example here, I just need the summation, so I'll keep it as it is. Now I'll connect that the 2x plus 2y by the du, or du by dt integrator. Now I have my du by dt ready, as well as the dx by dt. The only thing missing now is the dy by dt. dy by dt equals to y plus 7u. I have the u, I just have to multiply it by a 7. So I'll drag another gain, double click on it, change the value to 7, and press OK. Now as you see, the input of the gain is in an opposite direction to what I want. So I want to flip that block to look nice. To do that, just right click on your block, you have the list. Now go to format and choose that flip block. You can rotate it clockwise or counterclockwise, but right now I just want to flip it. So press on flip block and it's flipped. Now I can join my line and connect the U to the gain. The result, as you know, is gonna be 7U. To sum the 7U with the Y, I need another sum block, and it doesn't look nice also, so I will flip that one as well. The same thing that I did before. Okay, I'll put the 7U into one input, and I'll put this y anywhere that the y is. This arrow carries a y in it, so I'll insert it into the sum. Now the output of that sum will be y plus 7u, which is my differential equation, or which is the equation that I want. This is the input of my dy by dt integrator. So I'll connect it as an input to it, to the first integrator. Now I have my design ready. The solution of the Simulink is ready, except that output blocks are not there. So I have to insert some output blocks as the scope, for example. This scope, this is the icon. All of these icons or blocks are available in the commonly used block category. So this scope is to show you the sketch of each of your variables. For example, u versus t, y versus t, and x versus t. You can drag three scopes and display your result or your sketch in separate scopes or separate sketches. However, I want to do this in only one scope, and we can do it. But first, I want to show only u versus t in that scope, and then I will add the y and the x on different scales inside the same scope. So I will connect that scope with the u to show me the u. So here I will do just some modifications to my design here so that it will look more clear, it will look better. I will add colors. So for each integrator I will put a certain color. So for that integrator of dy by dt, I'm gonna choose a foreground color of, let's say, green. So right click on your integrator and then go to foreground color and choose any color that you like. I'll choose another color for x. I'll choose it to be, let's say, blue, and the u, I'll choose it to be red. Now any arrow that has y in it looks green, any arrow that has x is blue, and any arrow that has a u in it is red. So it's not confusing anymore right now. Before asking for Simulink to give us the solution, we have to insert the values that are given as the initial conditions and the range of the t. Let's start with the range of the t. It's over here at the top. You have some number. Change it to your final value. So for example, I have the t final here to be 1. I will put a 1. Another thing to insert is the initial condition for each variable. So for example, here I have y initial condition is 1, and x at time 0 is 2, u at time 0 is 0. So double click on your integrator of dy by dt and insert 1, and then press OK. Do the same thing for x, but it's 2, its initial condition is 2, and for the u it's already 0, but just make sure that you insert the right initial condition of your variable. Now I have everything ready, but please don't forget to press that start simulation button so you have your system solved. In a few moments it's solved, and you can double click on the scope to find that window and you find your solution. You see that it doesn't look that nice, so to get your scale fit, just right click anywhere in the black area and press auto scale. After you do so, your sketch will look perfectly nice and it's very obvious and clear. Now, as I said, we want to to show or present all of our variables versus time. This is u versus time only. To add all of your three variables into the same scope, you need to go to that thing here. It's kind of the settings or the parameters of your scope. Click on it and change the number of axes to 3 because I have 3 differential equations. You can put as many as you have. So I have 3 scales right now. Close it, and then you see that you have 3 or 2 ports are added to your input ports is added to your scope. You can now join the inputs that you want. So I need to join X, which is the blue, anywhere blue, and I need to join the Y, anywhere that's green will do the job. This is green, I'll just join it. So now I have Y, X, and U are inserted into the scope, and it can show me all of them. So let's start simulation, and then double click on my scope, auto scale every scale of these 3 scales, and I have my solution ready. Maybe you want to have your exact value of each variable at the end of your range of time, so it's not very clear from here from a sketch, so I need to display it. For doing that, I need another block. This block is called display. It's not here in the commonly used blocks category, but it's in sinks category. Go to sinks category and click on it. You will find the display block as the first one. Drag it, place it in the place you like. So for example, I want this one to show me Y. I'll place it somewhere near any place that's green, and I'll put this one here to display X value, and this one here to display the U value. Just to make it more clear, I will color each display with the same color of my variable. Make the first one green, second one blue, and the last one red. Do the same connection, the simple connection, for each display with the variable you want it to display. Now it's ready. As soon as you click on Start Simulation, you will have your numbers, and it's accurate numbers. So the Y, for example, is 243.3, the X is 215, and the U is 162.1. I hope you enjoyed this video and you learned something, and you found that Simulink is simple and easy to work with, and also kind of fun. Thanks for watching.